In the 2014 TV show Flash, one of the characters from the future states that he learned astronavigation in grade school. Now, this is nothing new because throughout our lives we do notice that things that were advanced for their time slowly become more obsolete or irrelevant. This extends to technology. This is the Turing machine, made by Adam Turing back in World War II to decipher Nazi codes, or as we would like to know it today as the first computing device. Now, this Turing machine is still the foundation to every piece of technology we use today. It is literally the basis of modern day computing. But what is computing? Well, computing is based on bits, and a bit can be in either two states, off and on. It's essentially like an electrical current, or a light switch. Actually more of a light bulb itself. Now, combined with logic gates, which can act more as a light switch, you essentially are able to create inputs and outputs of ones and zeros. And with this, you can essentially add them together. And by adding them together, that means you can also multiply. And after you multiply, you can essentially compute anything with given enough inputs, outputs, logic gates, and bits. So, that's how modern computing is essentially defined. Something that is just around the corner now is quantum computing, though. So here's where things get complicated. What is quantum computing? So, quantum computing is really difficult to explain in simple terms. So, essentially, the bits that used to be only off and on are now both. They can be in a state of pretty much an in-between state. Shohin Chos, a quantum physicist, said in her tech talk that it's like stirring a mixture of two fluids together. However, when you finally get the output, it definitely becomes one of those two options. Now, what does this mean? Well, this means that as a result of every bit being a possibility of one or the other at the same time, that means that as you add more bits, the end combination is literally every combination of those bits, including the one that you need. So what does this mean for computing? Well, it makes our computers incredibly faster. And while in normal computing, we would have to go step by step to determine something, with quantum computing, we can do it all at the same time. Leo Cohenhoven, a physics professor, says that, it finds the answer in a single step. Now, that's very hard to imagine, but it's true because of quantum mechanics. So, what are the global applications of such a technology? Well, but one of the main things is advancements in medicine. Because with quantum computing, you can actually simulate proteins and how medicines will react to them and how they're formed. And with that, you get more advancements in medicine because you know more about proteins. You also get a lot more protection since there is since every possibility is possible, if that's easy to understand. With quantum computing, secure keys are incredibly hard to decipher because it can be any possible combination. And finally, simulations. Because of how fast quantum computing is compared to what we have now, and how it also uses the quantum mechanics that are the foundation of our very existence, we can actually simulate our reality with more accuracy. But that's just the three things that people mainly describe as advancements when it comes to quantum computing. There actually is a lot more to how it will change our society on a global scale, and some theorize that it can lead to teleportation. Now, not actual teleportation, though that might be a possibility, but teleportation of data with no distance traveled. It's just immediate data from one point to another. There's also the possibility of artificial intelligence. Since quantum computing grows exponentially, with artificial intelligence that also learns exponentially, and with enough computing power, we can actually create more and more advanced AIs. But I feel like the biggest change that will come in our society with quantum computing is actually the educational system. Now, this goes back to what I said earlier with the guy from the future learning astronavigation back in grade school. See, right now we live in a generation where kids know how to use technology better than their parents did, even at such a young age. Now, with quantum computing potentially becoming mainstream, I feel that it will greatly impact the way we teach kids, because now we have more advanced forms of technology that they will get accustomed to at such an early age. So, the counter argument is that this will potentially lead into an over-reliance on technology for kids. But honestly, I feel that, we are a very technological society, and it's kind of too late to change that. I feel that no matter what, if we want to improve the society, we need to become more advanced in technology, or else we'll just stay stagnant as a species. Because if it wasn't for us advancing, we wouldn't have things like quantum computing. So that leads me to my conclusion, where, what will our kids learn in the future? Will they be accustomed to, not needing to worry about internet security, or, maybe farther into the future, games that can simulate reality way more advanced than anything we have now? It's very hard to say, but we see this happen in our daily lives, where something that was advanced further for its time just becomes more mainstream and becomes learned by younger and younger audiences, and understood by those audiences pretty well.